Okay, so looking at our binomial expansions, this question says find, in terms of k and x, the third term in the expansion of this. Now, we know how to do general terms in binomial expansions. Okay, we went through the easiest way to do this, and I also put up a video for you guys on it. Okay, we went through the typical behavior of a binomial expansion at any particular term. Okay, with this being said, we know for the third term, okay, that is when we are going to have, so inside the 10 choose whatever, okay, if the third term has 2 at the bottom, okay, because we said first term has 0, second term has 1, so third term has 2. Okay, this is what or is equal to. Or is equal to this number 2. Okay, so in our general expansion, our general terms expansion, okay, if I have something like x plus y to the power of n, okay, any term in that is going to be n choose or, okay, so 1 less than whatever, so third term or is going to be 2. Okay, then we have the first term, so the x to the power of the total, so in this case 10 minus the 2. Okay, so the total minus or, so n minus or, and then the second term from inside the brackets to the power of or. Okay, so in this one, it's 10 choose 2. Okay, then my first variable, so the x. Okay, that is going to have a power of 10 minus 2. Okay, and then the k over x, so the other bracket, has a power of 2. Okay, now I done another video on this, guys, where we saw how we could come up with this general formula. Okay, so if you're looking at this being like, I'm finding this really difficult, I'm going through it faster than I went through it in our previous video and when we went through it in class, okay? Look, I'm going to go and simplify this now a little bit. Okay, 10 choose 2, I can type that into my calculator and get 45. Okay, then I have x to the power of 10 minus 2, so to the power of 8. And then I have a k over x squared. So that means it is a k squared and it is over an x squared. Okay, so that over the x squared part, that x squared is on the denominator. It doesn't matter if it's on the denominator of one part or all of it. It is dividing by stuff that is multiplying. Okay, so remember, those have the same amount of value. Okay, if I'm looking at something like 1 times 2 over 2, okay, it doesn't matter if I do the division of 2 first or do the multiplication on the top line and then divide. Okay, so here, can this divide by anything on the top, or can this divide anything on the top line? Yes, it can divide into the x to the power of 8. So when I do that out, okay, we know that if we are dividing x's, that it's the power on the top line minus the power on the bottom line. So it's x to the power of 8 minus 2, which is 6, and then k squared. Okay, now the k part is technically a constant here. Okay, the x is the variable, so it is a little bit nicer if we write it as 45 k squared x to the power of 6. Okay, that is my third term. Now, it says the coefficient of x to the power of 4 in this expansion is this. Find k. So, in this expansion, I'm going to rewrite out what the expansion is here. Okay, so it wanted the expansion of x plus k over x to the power of 10. So if they're looking at the coefficient of x to the power of 4. Okay, it is not as simple as looking at when does that first term have a power of 4 on it. Okay, it's not that simple because in this one, there's also an x on the denominator over here. Okay, so it's not so simple as to wonder when does the power on the first term become 4. Okay, there's a little bit more to it here. So maybe perhaps look at what we done in part 1. Okay, how did this become x to the power of 6? Well, it was the n minus or from here, and then we took away that or again. Okay, so we had 10 minus the 2, and then the 2 from over here was taken away from it again. Okay, so we actually have the power on the x, okay, is the final power on the x in this question in particular, because there's an x in the denominator in the second variable. Okay, it's n minus or again. Okay, that's the final power that's on the x. So here it was 10 minus 2 minus 2. Okay, so here it's the coefficient of x to the power of 4. So we need to look at when do we get x to the power of 4. Okay, so when is n minus 2 or when is that equal to 4? Okay, so this is what we need to think about. Okay, we want to know what is or, what term is this on? Okay, n, we know it was a power of 10. Okay, so it's 10 minus 2 or is equal to 4. Okay, so minus 2 or is equal to minus 6. Okay, so that means that or is equal to 3. Okay, so or is equal to 3. So it's my fourth term in the expansion. Okay, my fourth term in the expansion. So I need to figure out what would the expansion have looked like on the fourth term. Okay, so we are going to find what is the fourth term of this expansion. Okay, so if we are going to do that, okay, the fourth term, it is going to be 10, choose 3. Okay, so remember, or we found is 3. It is 1 less than the term that we are at. So it's 10, choose 3. Okay, we already know what the final power on the x is going to be, but let's just do this anyway. Okay, it's going to be x to the power of 10 minus or, so minus 3, and then k over x to the power of or, so to the power of 3. Okay, it's nice to do this out fully anyway, because then we can see, do we definitely end up with an x to the power of 4? So 10, choose 3, put that into your calculator, we get 120. Okay, then I have x to the power of 7, k to the power of 3, and that is all over x to the power of 3. Okay, so when I simplify that, I'm going to get 120 k cubed x to the power of 4. So what is the coefficient on the x to the power of 4? It is 120 k cubed. Okay, now we know that this is equal to 7,680 x to the power of 4. So compare your coefficients. Okay, 120 k cubed is equal to 7,680. So let's find k. We need to get rid of indices, and we need to get rid of stuff that's multiplying. Okay, remember, if you're not sure what order to get rid of stuff in, you can use backwards BIMDAS. Okay, we have an indice, so the cubed, and we have something multiplying. So we get rid of what's multiplying first. Okay, so do that by dividing by 120. So that we get k cubed is 64. And then we get rid of a cubed by getting the cubed root. So I need the cubed root of 64. I can type that into my calculator to get that k is equal to 4. Okay, so k is equal to 4. My work is a bit messy, so I'll put a box around my final answer so that it can be followed.